Astro 521. This is Stephen Hawking, and I'll be discussing the possible exotic objects.
I won't actually keep that voice because it's too annoying, but this is my podcast giving a brief introduction to the hypothetical group of compact objects called exotic stars, which basically just means that they're made of matter other than electrons, protons, and neutrons. And I should mention, it seems I've taken the theoretical aspect of this project's description to heart, since exotic stars have yet to be observed and remain largely notional. I'll be giving a brief explanation of the supposed objects, quark and preon stars, and I'll start with and spend more time on the former, since preon stars are not only hypothetical as objects, their composite matter, the preon, has never been observed. So quark stars are sort of a theoretical analog to the neutron star. So instead of being made of neutron degenerate matter, they're made of quark matter or strange matter. This video demonstrates a possible evolution from a large massive star to a strange quark star, and we see the initial massive star leading to a supernova explosion and leaving behind a rapidly spinning neutron star. And it's possible that the neutron star could actually shrink further and for the neutrons to dissolve into free quarks and become a quark star, as seen here. Of course, one of the problems is there's a great deal to be learned about neutron stars, whose equation of state is still unknown. So the composition of the superdense matter at the core remains uncertain basically until the mass and radius can be simultaneously constrained. You can see in the slide these competing models mapped onto a diagram of a neutron star, with the different compositions predicted by different theories, as well as a number of equations of state plotted in mass radius parameter space. Now, in quantum chromodynamics, ordinary temperatures and pressures will confine the quarks into composite particles, which we call hadrons, and they're at a distance of about a femtometer, 10 to the minus 15 meters. In quark or QCD matter, however, the energy is sufficiently high, and the matter is either hot or dense enough to have broken the hadrons into their constituent quarks. This happens either at temperatures around 10 to the 12 Kelvin, or if the quark separation becomes less than a femtometer and the density increases. Seen here is a QCD phase diagram of temperature and density showing the critical curve beyond which hadrons are decomposed into quarks and gluons in a plasma. And it turns out that the cores of neutron stars probe the low temperature and high density region of the diagram. So while young neutron stars can start out with temperatures as high as 10 to the 11th or 10 to the 12th Kelvin, the temperature quickly falls to about 1,000,000 Kelvin from neutrino cooling, which is much less than the hundreds of megaelectron volts required for quark matter at nuclear densities. It is, however, possible that QCD matter could exist at the core of exceptionally massive neutron stars because the densities are known to be several times greater than the nuclear densities. And this would basically melt the neutron degenerate matter into its up-down constituent quarks, with some of them becoming strange quarks. In the same way, a neutron star can roughly be thought of as a giant nucleus. The quark star can be thought of as an oversized hadron, which is bound by gravity rather than the strong force. Now, while quark stars still have the status of almost entirely hypothetical objects, there are a few exotic star candidates which seem to be smaller and colder than expected for a neutron star. These observations have been met with great skepticism, but it's possible they're too dense to be composed of neutron degenerate matter. You can see a photograph of RX J1856 in the optical band and an X-ray false color of 3C58. Now again, if you look these objects up in SIMBAD, it's not going to say quark star. They've simply been proposed as candidates. Now on to preon stars. It's indicative of the preon star's relevance that I couldn't find a diagram of one after 1980, but they're at least interesting objects. Preons are the theorized subcomponents of quarks and leptons, whose motivation was largely to be able to organize the particle zoo, similar to the way the periodic table organizes the elements. The idea being for stars that the pressure would be greater than a quark star and could cause these quarks and leptons to be further reduced to the point like more fundamental particles, preons. Of course, neither the compact object nor the particle has been detected, and preon theory has lost much of its incentive in the past couple decades.
Hopefully you've enjoyed this introduction to the adolescent research area of exotic compact objects.